Okay, I'm going to go over a bunch of different exponent rules. Good little cheat sheet here to have. Anything to the 0 power equals 1. Negative exponents. So if you have a negative exponent, you actually write it as 1 over and you make the exponent positive. If you have a product with the same base, meaning the big number, or could be a variable, then you add the exponents. If you have the same base and you're dividing, then you subtract the exponents. The power of a power, do some of these where you actually just have to bring in this power and multiply it inside here. If you have more than one term, you have to be sure each term is given that power, and the same as dividing. So let me first mention a couple of things that I see students mix up. If you have -3 squared versus -3 quantity squared, this one means -3 times 3 times 3. So that would be -9. Where this one actually means -3 times -3. So that would be a +9. That is one that just gets mixed up all the time with students. All right, let's do some exponent rules. So if I have x to the 4th times x squared. If you didn't have these rules, then what you would be doing is you'd say, okay, there's 4 of these, 2, 3, 4, and there's 2 of these, 1, 2. How many do you have total? 4, 5, 6. Remember on this last sheet right here that we have the same bases. We just simply add those exponents. So I can just simply say x to the 4 plus 2 and see that's how we get the x to the 6th power. Works with numbers, of course, as well. If I have -2 to the 3rd power multiplied by -2 to the 7th power, I can rewrite that as -2 to the 10th power. 3 plus 7. I can do a combination with numbers and variables. So let's say 6z to the 10th, -2z to the 7th, and then z to the 4th. All of these are being multiplied. I can see that I have some numbers here that I can multiply. So that would be -12. And then my z's would be 10 plus 7 plus 4. And that's how I would get to the 21st power. So definitely learning this rule right there is a good one. And notice that I had the same bases here, and even here with the z's, the same bases. All right, so next if I have something like 2z to the 4th squared. Again, if we didn't have the rules, then you would just say 2z to the 4th times 2z to the 4th. And then you could break these down as well. But in this case, our rule says you can actually bring the 2 inside and multiply by every single term. So that's really like 2 to the 1st power, right? So that would become 2 squared. And then once again, our rule of adding 4 plus 4, which then becomes 4z to the 8th power. When these get nice is if you have something like x to the 6th, y to the 4th squared, then I can see this would be x to the 12th, y to the 8th, because once again, 2 times 6 and 2 times 4. All right, so looking once again, that's this rule right here. So even if I have something like a fraction, let's say like x over y to the 5th power. Well, again, even if it's a fraction, you could write that x over y times x over y times x over y, or just be sure you're putting it on both terms. Okay, so you're bringing it on that term and that term as well. All right, so I want to look next. This is a very, where did it go? Right here. Good property to know. So let's say that I have something like x to the 5th power over x to the 3rd power. And you could do this, right? 1, 2, 3, 4, 5, and 1, 2, 3. And you could see those would cancel, and you end up with just x times x, which would be x squared. Or you know that rule that when you are dividing with the same bases, you subtract the exponents, and you get the same answer. Again, can do the same thing with numbers, say -2 to the 6, -2. I mean, the important part is the bases have to be the same. Okay, so what am I calling the bases? This big number, our variable, and these are the exponents. And so here I can do the same thing, -2 and then 6 minus 3. So -2 to the 3rd power, which would be -2 times -2 times -2, and that would be -8. All right, another rule, let's see, that I saw on here. Anything to the 0 power is 1. So if I have this whole quantity, 8x to the 0 power, anything to the 0 power is 1. But be careful if I have something like -8x to the 0 power. The -8's out front, x to the 0 power is 1, and so I get -8. Another rule I want to look at is this one right here. This you see a lot in science courses when you have negative exponents. So let me write this out here. So 3 to the -5 based on that property is 1 over 3 to the 5th, which would be 3 times 3 times 3 times 3 times 3, which would be 1 over 243. I can do the same thing with variables. -7. Notice that 8 just stays the same, but that would become 1 over x to the 7th, which I can now write in this form. So you want to be careful anytime you have negative exponents. Typically you move those to the denominator. If I had something like, let's say r and then r to the -2, r to the -6. Okay, that's kind of weird, right? Well, probably what I would do is these are being multiplied, so I would go ahead and add them first. -2 plus -6 is -8. And then remember our rule, this is really r to the 1st power, and you subtract, so I would get r to the 9th power. Remember, when you're dividing, you're subtracting those exponents. And again, can get something a little bit more crazy with, say, like 2ab to the -1 over 2 to the -1, a to the -8, b to the 3rd. What I probably would do is separate each one of these, -1, and then times a over a to the -8, and then times b to the -1 over b to the 3rd. And so now this way you can actually go through and subtract. Remember, that's like a 1 there. So 2 to the 1st power minus -1, a to the 1st power minus -8, b to the -1 power minus 3. So this is going to give me 2 squared, a to the 9th power, b to the -4 power. And if I can get my screen to roll down, this would be 4a to the 9th. And then why not bring that negative power back down to the bottom? So a lot of it is just really getting comfortable with these rules. Once you get these rules down, okay, you'll see that you just go through working these and follow those rules.